Looking at our last section on conics, we are looking at ellipses or an ellipse. So again, we're going to have similarities to yesterday's lesson on circles. It's going to be circles plus a little more. So an ellipse happens, we see in this third option, where a cone is cut in such a way that the plane that we're cutting it with goes through completely through the cone, but not parallel to the base. So we get that oval shape, which we would call an ellipse. So we are going to look at graphing those today. So the formula for an ellipse looks fairly intense, but what we see here is the formula for a circle, which makes sense since an ellipse is just a stretched out circle. And it's actually going to have two different radii, an X radius and a Y radius. And this symbol right here, this pound or hashtag X, is the X radius. And then this one here is the Y radius. And then we square them as a denominator. Both of those radii are in the denominator spot of those fractions. So we have a modified version of the circle formula. So let's look at this in action a little bit. We see an ellipse graphed already for us, and we are asked to identify H and K again, which are still the center of our circle, right? So H is tied to X right here, and the opposite of what we see. So it has an H value of 3. K is tied right here to Y, and again is the opposite of what we see. So it has a center point at 3, 4, right, which we see right here. The X radius is going to be come from this value right here, the 16. 16 is X radius squared, so the X radius is 4. And we see that right here, right? We go over 1, 2, 3, 4 units from the center to the edge of the ellipse. And our Y radius is the square root then of this 25, which would just be 5. And again, we see it here, up 1, 2, 3, 4, 5 units. We have a very stretched out circle here to make this ellipse. And H and K are going to be in the parentheses here. There is nothing being added or subtracted from X, so I have an H value of 0, and I have a K value, the opposite of the 2 there, which would be -2. So I have a center point right here. So looking for the 2 radii, square root of 1 is 1, and this 49 square rooted would be 7. So that is our information from that ellipse, right? Everything to do with X is all in this first term, and everything to do with Y is here in this term, right? H and K are still being added or subtracted to the X before it gets squared, and our new radii, plural, are in the denominator spots. So we're just taking information out here. There should be a line right here. But looking for H and K, H is right here, opposite of 2. And K comes from right here, opposite of -6 would be the +6. So this circle or ellipse is going to have a center point at -2, 6. Looking at the 2 radii, square root of 9 for the X radius, and square root of 64 for the Y radius. Go ahead and try part B on your own, and then we will come back together and talk about it. So looking at part B, I have an H value that comes from right here, the opposite of 2, or -2 is 2, and my k value is the opposite of -8, which is 8. So a center at 2, 8. My 2 radii, the x radius, square root of 16 is 4, and the y radius, square root of 100, is 10. Again, try C, and then we will talk about it. So for part C, you're going to have an h value of 5 and a k value of 0. Right, so 5, 0 is your center point. Square root of 4 is 2, and the square root of the 81 is 9. Doing some graphing here, we have x, nothing being added to x, and nothing being added to y. So I have a center point then at 0, 0. So here's my center point. I have an x radius of 4 and a y radius of 1. This one's going to be fairly unpleasant to draw to try to make it rounded. I did not do a very good job there. But again, when we're drawing these, just making an effort so that they are not diamonds. Do your best to make an ellipse. I'm going to pop down to example F to leave some for you to do on your own. My center point is going to come from right here, right? The opposite of 3 and the opposite of -4. So -3 up 4 is my center point. And then I'm going to have an x radius of 5 and a y radius of 2. Square root of 4 is 2. So again, I'm going to do my best. Again, not perfect, but you get the idea. If you need help or you want a more perfect graph, you can use Desmos. So x plus 3 squared. And then if I hit the divided by sign, it just pops right into the denominator. Hit your right arrow to get out of denominator mode. Right? Y minus 4 squared over 4. And then equals 1. Right, so I see that oblong circle, not really circle, oval, which mathematically we should be calling an ellipse. Right, so the Desmos version and my version are similar, at least. Theirs is obviously true and perfect, where mine is kind of not. Lastly, just writing some equations. So just kind of setting up that generic format. These are all equal to 1, so that helps. Nothing here is getting added to x, so it'll be x squared. And then my y part is going to be y minus 8 being squared. And then my denominators are the respective radii squared. So x radius squared is 9, y radius is 25. And then I will let you take a moment to try the second one here on your own. So again, setting up the generic format. I have an h value of -4, so opposite goes in. H plus 4 will be x plus 4 squared. And then I have an x radius of 4. 4 squared is 16. And then I have y minus 2. A y radius of 7. So 7 squared is 49. So that is it for our chapter on the ellipse.